Hello. Yeah, I think my voice is clearly audible, right? So for CIL Coal India Limited, we are going to solve some very good questions. CIL CBT. Yes, topic is power system. Okay, good question. So that your concept will be revised from these questions. Okay, day before yesterday on Tuesday, I remember we did network analysis, right? Some 30 plus questions we solved on network analysis. Same way for power system also we are going to do. See, do remember one thing, class is for learning, not for mugging. Okay, class is for learning. So learning is very important in class, right? Very important learning. Now let's read the first question. What first question is saying? What is the surge impedance loading of a lossless 400 kV 3-phase 50 hertz overhead line of average of surge impedance of 400 ohms? He is asking about surge impedance loading. What is surge impedance loading, sir? First of all, what is surge impedance, sir? Surge impedance is the impedance offered by the transmission line or equipment for sudden changes or surges. Surge impedance is the impedance offered by the transmission line for surges or for sudden changes. Okay. So for a lossless line, surge impedance will be, I'm going to give some 3-4 formulas for surge impedance. Okay. ZC is equal to under root of R plus J omega L. J omega L is nothing but XL, means JXL, right? G plus J omega C. G plus J omega C, right? R plus J omega L by G plus J omega C ohms. This is for a lossy line, means transmission line is having resistance, means see when this formula means, sir, when I have to apply this formula, if a transmission line is given as distributed parameter model. What is distributed parameter model, sir? Yes, this is distributed parameter model, man. Resistance, inductance, shunt conductance, and capacitance, and this continues. So this is a distributed parameter model. For this kind of model, yes, this is R per km, this is L per km, this is G per km, and this is C per km, and it continues, R plus J omega L by G plus J omega C for a lossy line. For a lossless line, yes, see, this question is damn easy. You should not think like, sir, you are wasting a lot of time for solving that question. No, that question related all the concept I am giving here, so that it's going to be useful for you when any related question also appears in the examination. Okay, for lossless line, that is R is equal to 0, comma G is equal to 0, ZC is equal to under root of J omega L by J omega C, J omega gone, under root of L by C ohms, right? But fortunately or unfortunately, that fellow given the value of ZC here, okay, ZC, that fellow given as 400 ohms. One very important point here is ZC is independent of, yes, independent of length of the transmission line. Yes, characteristic impedance does not depend upon length of the transmission line. For a 20-kilometer line, if it is 400 ohms, so for a 200 kilometers of the same line, means just length is increased, configuration is same, then it is going to be same 400. Right now, surge impedance loading, SIL, this is in megawatts. Load means power, that too real power. Surge impedance loading is always in megawatts, not MVAR, not MVA, not MVAR, not MVA. It is always in terms of megawatts. megawatts, right? Surge impedance loading in megawatts is equal to what? V square by ZC. What is V? Voltage V. V is 400 kV. Sir, this 400 kV is which voltage? Is it sending end or receiving end? Always the given voltage is receiving end. That is a fundamental. Always. If nothing has been mentioned, always the given voltage is taken as receiving end voltage. That's point one. Right? That is receiving end voltage. And that is a line voltage, not phase voltage. Right? So then in power formula, which voltage I have to put? If you are putting here line voltage, suppose if it is V line to line whole square by ZC. Now what is V line to line? Root 3 times of V phase whole square by ZC. That is equal to 3 into V phase whole square by ZC. That is 3 times of surge impedance loading of single phase. Of what? Single phase, right? So this is what? 3 phase. This is what? 3 phase means. If you take directly line voltage here, you will get 3 phase power directly. If you are taking per phase voltage, you will get per phase power, and if you want 3 phase power, you have to multiply with the 3. But why all this? Just that fellow given line voltage directly. What is that? 400 square, 400 kV square. kV square will be mega. I'm writing here mega. kV square. K means 10 cube. 10 cube square means how much? 10 to the power of 6. 10 to the power of 6 means it is going to be mega. 10 to the power of 6 means it's going to be mega. 10 to the power of 6 divided by the ZC value is 400. 400, 400 times will get cancelled. So that is 400 megawatts. 400 megawatts. Option is A. A for apple. Right? Question is the simplest question. You may be thinking, sir, you explained all the story. Yes, that is the purpose of this class, to learn the concept related to this entire, right? 400 megawatts. So very good learning here for lossless line, for a lossy line. Okay, what is the surge impedance? And surge impedance is independent of length of the transmission line. And when you are applying this formula, you must be very cautious that if you take this voltage as line voltage, directly you get 3 phase power. Suppose if you are taking this one as single phase power, per phase power, not single phase, per phase voltage. Per phase voltage, if you take, you will get single phase power. If you want 3 phase power, you have to multiply with 3. You have to multiply with the 3, right? Yeah. Try to answer this question, please. Okay. I'm giving you 2 minutes of time. After that, I'll take up the concept. Try to answer this. People may feel like, sir, we need a calculator for answering this question as it is involving complex calculation. Nothing doing. Very simply, you will get. Very simply, you will get. Please try to answer. Yes. Yeah. So he's asking, DS is the GMR of each subconductor. Okay, he given, see, let's read. Anyone with the option? Option is D. Yes, Mr. S21. Yes, in previous networks class also he answered. Very simple. So he's saying each subconductor of a four subconductor bundle conductor. There are four subconductors. Four subconductor, conductor A, conductor B. Sir, how we have to arrange four subconductors? That is given by him. He is saying that D is the bundle spacing. Now, in which physical structure spacing is fixed, constant between all four? Is square. Yes. Yeah, he given the bundle spacing is D. This is D. Okay, accepted. This is D. Accepted. This is also D. Accepted. Anyhow, this is also D. Accepted. Right. Now let's take this one as one, two, three, four. Right. Let's find GMD. See, each subconductor is having its own radius, effective radius as ds, which is called as GMR. GMR is effective radius of the conductor in which self-magnetic flux linkages occurs. GMR is, yes, what is GMR? It is the effective distance over which self-magnetic flux linkages occurs. Okay, so GMR of 1, or that is also called as self GMD. So self GMD of 1 is equal to 1. Its own is how much? DS. He's saying that its own is ds. Okay, into 1 with 2. What is the distance? D. 1 with 4, distance is D. 1 with 3, we have to find the distance, how much it will be. Apply right angle triangle. Right angle triangle. This square plus this square is equal to this square. D. Root of d square plus d square is root 2d square. That is root 2 times of d. 1, 2, 3, 4. 1, 2, 3, 4. Total 4 distances. So this is going to be fourth root. Fourth root of ds into d cube into root 2. Now the question rises here. Sir, that fellow taken 1.09 outside, but I don't know what is the fourth root of square root of 2. Not required. Look at all four options carefully. D cube is there in this one, this one, this one, this one. Okay, forget about D cube. DS is there in all, but see, ds cube is there. This is not correct. Ds should be there. This is ds cube is there, which is not correct. Only one ds should come. Ds cube is there. Ds cube is there. These two are not correct. Now among these two, one will be the answer. So there should be fourth root in the first option. Fourth root is missing. Therefore, option D is answer. So people claim, sir, no calculator. I don't know how to find fourth root of square root of 2. That's why I'm unable to do. But that way of thinking is not correct. That way of thinking is not correct. Okay. So if you observe carefully, option B and C are blunders. Why? Because they are having ds cube, which should not be there. Ds cube is there, which is not correct. In option A and D, exactly matching except that fourth root. In the answer, fourth root should be there. Therefore, I can say this option A is not correct. Option D is correct, right? Let's go to the next question. Very good question. Very good question. Try to solve this question. All these questions are previously asked questions in various examinations. These are not my own questions, please. So think that you are solving for some, you are in some examination all and you are solving. Okay, do it. Yes, I'm waiting. One more hint. This question is almost related to Ferrand effect. Yes. Yeah, what he's saying. The ABCD constants of a three-phase S21 said answer as BB for Bombay. It's a very simple question, man. The ABCD constants of a three-phase transmission line are A, D given. A should be equal to D. If some question is given which is A is not equal to D, that is not a practical transmission line. And definitely AD minus BC must be equal to 1. For a practically existing transmission line, A must be equal to D and AD minus BC is equal to 1. Right? The sending end voltage is 400 kV and the receiving end voltage under no load condition. See, damn simple question. I given you the answer also. So very simple. Even if you are not remembering anything, you can remember this one at least. Vs is equal to AVR plus VIR. Yes, from the same, Is is equal to CVR plus DIR. Now from this one, observe carefully. From this one, under no load. Yes, under no load means what? Under no load, that is IR is equal to 0. What do you get? Vs is equal to A, VR not stands for this stands for no load receiving end voltage. Receiving end voltage. So VR not is equal to Vs by A. What is Vs? 0.8 by A. No, Vs is not 0.8. Sorry, mistaken. What is Vs given by him? 400. 400 divided by magnitude. I want this magnitude. All magnitudes only we have to take. How much is A magnitude? Sorry. Yeah. How much is A magnitude? A magnitude is how much? 0.8. Yeah, 400 divided by 0.8 will be, it is simply 500 kV. Option is 500 kV at an angle of -1. Right? Option is B. Option is B. Okay. Only one person is answering that S21%. Remaining, no one is answering. Okay. Try to answer this question, please. Try to answer this question. Okay. So this is about positive sequence, negative sequence, and zero sequence impedances of a transmission line. Okay, impedances of a transmission line. Yes, answer please. Yes, what is saying? The parameters of a transposed, yes, transposed. This carries heavy meaning. Transposed means a positive sequence, negative sequence, zero sequence. Means I can say transposed means phase A, phase B, phase C are equal. Okay, so if it is not transposed, phase A, phase B, phase C, GMDs are not equal. If GMDs are not equal, the reactants are also not equal. Or a transmission line, XS given, XM given, the positive and zero sequence. Or why I did not ask about negative sequence? Positive sequence and negative sequence both are equal. See, Z1 is equal to Z2 is equal to ZS minus ZM, and Z0 is equal to ZS plus 2ZM. Okay, ZS plus 2ZM. So these are the formulas. But he is asking about reactance. Means we can neglect the resistance as that is not given by him. knowingly we are not neglecting, but that fellow did not given. So z is equal to r plus jx, r is equal to 0. Jx you write on both sides, jj will get cancelled. You'll be having this one. He's asking about positive sequence, zs minus zm. How much is zs? Nothing but xs. 0.4 minus 0.1, that is 0.3. This is 0.4 plus 2 into 0.1, 0.2, that is equal to 0.6. You see, and one very important relationship, that is z naught is approximately equal to 2.5 to 3 times of z1 or z2, because z1 z2 both are equal. You see, this is 0.3, this is 0.6, almost actually it should be 2.5 to 3 times, but it is here 2 times. In this example it is 2 times. Okay, yes, let's go for next question. Yeah, read the statement and pick up. So this kind of questions are actually dangerous questions in your examination. These kind of questions are really dangerous. Why? Because statement wala questions, people will confuse, and in confusion they pick a wrong statement. Yes, yes. What is saying? Anybody with the answer? Option C. Mr. Kumar saying option as C. S21 also saying option as C. It's okay. Let's read. Self GMD of a conductor depends only upon the spacing between the conductors. No, self GMD depends upon conductor radius and bundle spacing. Radius and bundle spacing, these two will decide. Bundle spacing, these two will decide. Okay, mutual GMD between conductors, GMD itself is mutual. Okay, conductors depends only upon size, shape and spacing of the conductor. No, that is nothing to do with the size and shape. Yes, that is nothing to do with the size and shape. Okay, so mutual means GMD. So this conductor to this conductor distance, that's all. This is A, this is B. This conductor to this conductor distance will decide about GMD, right? Nothing to do with the radius of this conductor and shape of the conductor. Option C. Self GMD of a conductor depends only upon the size and shape of the conductor. Self GMD depends upon option C is also not fully correct. Self GMD of a conductor depends upon, yes, correct. The reason is, what is the difference between GMR and self GMD? If you take a conductor, only one conductor is there. It's not bundle conductor. R is the radius. It's a GMR is R dash. GMR is equal to what? R dash. If you take a group of conductors, yes, suppose conductors are this way. This is the shape. 3 conductors are there, which are arranged in the triangular form. That is a shape. Yes, that is a shape. Yes, center to center, center to center, center to center. That is a shape. Right, option C is perfectly correct. Right, as I told you, these kind of questions really will make you trap. Space is also required. In which option you are talking about? Yeah, bundle spacing. That is called as bundle spacing. So he's saying, na, size, shape. See, the self GMD of a conductor depends only upon size, shape of the conductor. Means this total itself is taken as conductor. This total is taken as conductor, bundle spacing. But better if it is added and bundle spacing, not just spacing, Mr. S21, bundle spacing. This is previous engineering service examination question. Okay. Yes. Yeah. Bundle spacing, not just spacing, right? Try this question, please, all of you. Try this question. Related to corona, electrical corona. Yes, what the question saying? The corona loss on a particular system at 50 hertz is 1 kilowatt per phase per kilometer. What will be the corona loss on the same system with the supply frequency 25 hertz? Supply frequency is reduced to 25 hertz. Yes, let me write the formula for corona. Let me write the formula for corona loss. And let me explain each and every term in that. Corona loss is equal to 241, something, some textbooks they given 242.5 like that, but let's take it into 10 to the power of minus 3 into f is present frequency plus 25 divided by delta under root of radius of the conductor by d is the distance between the conductors, not the diameter. People will get confused. Sir, r is the radius, d is the diameter. Radius by diameter will be 1 by 2 under root of 1 by 2. That will be 0.707. No. R is the radius, d is the distance into V minus VC, V phase in fact, minus VC whole square, kilowatt per kilometer per phase. PH is the present voltage. What is VC? VC is critical voltage for which corona takes place. Critical voltage, and this formula is applicable for all V phase is greater than VC. Mathematically, people will think like this. Sir, if V phase is less than VC also, something negative whole square is still positive, some value will get, but nonsense, which we have to keep in our pocket. Why? Because corona itself will happen if the present operating voltage, this fellow, is greater than this fellow. Yes, corona happens, critical voltage, corona loss happens, corona loss happens if V phase is greater than VC, otherwise it's not going to happen. Otherwise it's not going to happen, right? Yes or not? Now 50 hertz 1 C, corona loss is directly proportional to F plus 25. So corona loss 2 in the second case, why? Because everything is not talking about, he's talking about, sir, what is delta? Delta is called as air density factor that depends upon atmospheric conditions like pressure and temperature and humidity, these kind of things. So 0.392 into P stands for pressure, by 273 plus temperature T. Okay, right. So that is equal to, what is that? F2. How much is F2? 25 plus 25 divided by F1 is 50 plus 25. Right. Now corona loss 2, PC2 is, corona loss 2 is equal to PC1 is 1 into 50 divided by 75. So how much it is? 25 twos, 25 threes, 0.667 kilowatt per kilometer per phase. Kilowatt per kilometer per phase. Option is C. C for Chennai. Right? Simplest question. But just I thought of covering the entire corona loss formula in detail. Right? Yeah. So this question is on SAG, concept of SAG. Yes. Answer, please. This is very simple. What he's saying? He's saying very simply, for a 66 kV line having span of 200 meters between towers, the approximate sag will be 2 meters. Okay, if the span is doubled, sag is, what is sag formula? Sag is equal to WL square by 8T. What is W? W is weight per length, weight per meter per length. Okay, L is the length in terms of meter, in fact span length. L is what? Span length. Span length in meters. T is tension or tensile strength. Tensile strength, right? So sag is directly proportional to L square. S2 by S1 is equal to L2 by L1 whole square. So S2 is equal to S1 into doubled, it will be 4 doubled. L2 is 2 times of L1, L1 got cancelled. 4 into S1. How much is 2 meters? How much it is? 8 meters simply. Option is D, D for Delhi, right? Only one person answered. What about others? Try this question, please, all of you. Try this. Yes. Answer, please. What is saying? If the insulation resistance of a 2-meter long sample of a cable is 10 mega ohms, then 8-meter long sample of the same will have an insulation resistance of, insulation resistance of a cable is equal to rho insulation by 2 pi L into ln of capital R by small r. What is capital R? It's total cable radius. This is core radius. Small r is core. This is capital R, right? Now, insulation resistance of a cable is inversely proportional to length of the cable, right? Now, R insulation 2 by R insulation 1 is equal to L1 by L2. So, R insulation 2 is equal to R insulation 1 is how much? 10 mega ohms into how much is length? L1 is 2 meters by 8 meters, right? This is 4. 10 by 4 means 2.5 mega ohms. Option is B, B for Bombay. Only one person is answering. What about others? What about others? Only one person is answering. Why? What happened to others? Yes, come on. What happened to others? What happened, man? My screen is visible, all of you? Come on, Mr. S21. Yes, screen is visible. Only this S21 is answering. What about others? Respond, man. Hello, am I audible? Screen is not visible, Mr. S21.